we're going to finish up the 5C notes, and then the third part will be me using MyLabs Plus. So this time we're going to, instead of substitution, we're going to use a thing called elimination. Now elimination is kind of a weird one. Really, we're just adding up both equations and hoping one of the variables will go away. Now the first one is set up to work. The rest of them will not. If I were to add these equations together, if I add up this column, that's negative x plus negative 2x, that's negative 3x. When I add up the next column, y plus negative y, that cancels, doesn't it? Equals negative 3 plus 6, which is equal to 3. So if I divide each side by negative 3, I get x equals negative 1. Now that seemed super easy, but it was also set up to be super easy. If I have x equals negative 1, then I got to put in the other one, so I'm going to use this first equation here of negative x plus y equals negative 3. So now this is going to be strange. I'm going to do negative 1 plus y equals negative 3. So I get 1 plus y equals negative 3. I subtract 1, I get y equals negative 4. So really my first question here is negative 1 comma 4. That's my answer to the first one. Now, if I wanted to look at this, I'm going to rewrite this equation. Negative x plus y equals negative 3. Negative 2x minus y equals 6. Now, I eliminated the y's. Now, I want to show you I could also eliminate the x's, but it's more work. But I also want to show you get the same answer. Now, if this is negative 2x, I would want this top one to be positive 2x, wouldn't I? Because negative 2 plus 2 would go away. So right now there's a negative 1 there. But if I multiply everything by negative 2 in this equation, negative 2 times negative x, I'm going to rewrite it right there. That's positive 2x. Negative 2 times y is minus 2y equals negative 3 times negative 2 is positive 6. So let's add these two equations together now. Negative 2x plus 2x, the x's now are eliminated. Negative y plus negative 2y is negative 3y. 6 plus 6 is 12. I divide each side by negative 3. I get y equals negative 4. And that's exactly the same thing, isn't it? Okay. So if they don't easily eliminate, then I do have to do some work. Like this next one here. If I add up everything, 3 plus 4 is just 7x. That doesn't eliminate. Negative 5 plus 3 is negative 2. That does not eliminate. So now, the last one I can just multiply by 1 and get the answer here. Now, if this is positive 4, I want this to be negative 4. But 3 times what is 4? Yeah, I don't know what that is either. Nor do I know 3 times what is 5. I don't. So now this time it's even harder. Now I have to multiply each equation by something different. I'm going to look at the y's because one of them is negative, one of them is positive. Now we're going to go all the way back to unit 1. What's the least common multiple for 5 and 3? Well, it's 15. What I want to do is I want to make them both 15y. So 5 times what is 15? So it's 3. So I'm going to multiply everything by 3. I'm going to rewrite the equation over here. 9x minus 15y equals 33. Right, write a 3 there. Now 3 times what is 15? Well, I'm going to multiply everything by 5 in this time. 5 times 4 is 20x. 5 times 3 is plus 15y. 5 times 5 is 25. So when I add these together, 9 plus 20 is 29x. Negative 15 plus 15 is eliminated. 33 plus 25 is 58. Divide each side by 29. I get x equals 2. Now I still have to find out the y value. Now I could use any one of these equations. None of them are great. But I'm going to look at this one because they're all positive numbers. So I'm going to do 4 times 2 plus 3y equals 5. 8 plus 3y equals 5. subtract 8. 3y equals negative 3. Divide by 3. I get y equals negative 1. So my answer is 2 comma negative 1. Okay. I expect lots of questions on the elimination and substitution method. I think this makes this section extremely hard. So please, please, please come to class with lots of questions. Now, as a quick review here, when we were doing substitution method, we really were looking for a coefficient of 1 on one of the variables. If there is one, then the substitution method is a really good idea. Substitution. And if they have no coefficients of 1, just like this one right here, there's 3, negative 5, 11, nothing has a 1 coefficient. So really, that's the elimination method is the best way for that question. Alrighty, now we have one kind of word problem here. There's multiple ones, but they're all kind of a similar setup. And so we're going to set up, we're going to get two equations, and then we'll use elimination or substitution. And to be honest, I'm going to show both of them just so I can review both ways. So we're going to a Nationals game. 11 people are. And so we spent $449. Infield seats cost $44. And then the roof seats cost $37. How many of each kind? Well, I'm going to let X equal the $44 kind, $44 tickets, and the Y be the $37 tickets. Now I do know they sold 11 tickets, so that means the first equation is X plus Y equals 11. And to be honest, I don't know why, this is always the harder of the two formulas to get. Now the other one is the money. Well, each the X ticket costs 44, so it's 44 times the number of those tickets, plus 37 times the number of the Y tickets, equals $449. I am going to do substitution first, because I did substitution before first. Now what's nice is I could solve for either X or Y in this. Now I would never solve for a 1 in this one. Since we're so used to solving for Y, I'm going to solve for Y. So if I do that, I'm going to do this in minus X. So Y equals negative X plus 11. What I'm going to do is I'm going to substitute this in for Y there. So I have 44X plus 37 times negative X plus 11 equals 449. So when I get here, I have to distribute this. So it's 44X plus negative 37X plus 37 times 11 is 407 equals 449. Okay, so 44 minus 37, that's 7x, plus 407 equals 449. So I have to subtract 407. 7x equals 42, sorry. Equals 42, divided by 7, I get x equals 6. So that means I have 6 $44 tickets, and I'm going to definitely use the x plus y equals 11. 6 plus y equals 11. Subtract 6, I get y equals 5. So I have 5 of the $37 tickets. So now, let's do it the other way. If I have x plus y equals 11, and I have 44x plus 37y equals 449. Now, I could try to get rid of the x or the y. 37 is a smaller number, so I want to get rid of the y's. So if this is positive 37, I want this to be negative 37. So I'm going to multiply each side by negative 37. When I rewrite that, I'm going to rewrite underneath it, it's negative 37x minus 37y equals, what's this, negative 407. And this is math is going to look very familiar. 44x minus 37x is 7x. 37 minus 37, that's canceled. 449 minus 407 is 42. Pretty darn similar, isn't it? And I get x equals 6. I put it in, and then I get my y equals 5. Same answer either way. I do think most people like substitution a little better, but there are people, elimination a little better, but some people definitely like substitution. But if you are doing substitution, you come up with fractions, please stop. And the last part here, this is a nice part, and this will again be on the how to use the graphing tool on the MyLabs Plus. Because we are graphing inequalities now. So we're going to treat it like a normal line. So if I have 2x minus y is less than or equal to 6, I have to solve for the letter y. So I'm going to subtract 2x over. Negative y is less than or equal to negative 2x plus 6. And I have to divide everything by negative 1. And I really start off with this one first to remind everybody this. I'm dividing everything by negative when it's an inequality, so now it is now greater than or equal to 2x minus 6. I have to flip that. So now if I treat this like a normal graphing, I'm going to go down 6 because this is my y-intercept. 1, 2, 3, 4, 5, 6. My slope is 2 over 1, so I'm going to go up 2 over 1, up 2 over 1. Now, since it's less than or equal to or greater than or equal, these are solid lines, solid. So I'm going to draw my solid line. Now, I like to think greater than means I'm on top of it. I'm above the line. So this is on the line. This is above the line. And there's my graph. And I will show you how to do that with the MyLabs Plus tool. It'll look so much nicer than what I'm doing. My next graph. Now the next of them, I put all in y-intercept form to make it a little bit easier. My y-intercept is 2, so I got to go up 2, 1, 2, plot my point. Again, these will be a little messy because this is all hand drawn. So negative 1 over 3, so it means I go down 1 over 3. Now if you notice, this is just greater than or less than or greater, always dashed lines. So when I draw this, I have to make sure I draw a dashed line. And now it's greater than, so that means I got to be on top of the line. So on top of the line is above there. Now I'm going to do a quick review of old stuff here. Y is less than 3. Now you remember y is less than 3 is a horizontal line because it has 0 slope. I go up 3, 1, 2, 3, plot the dot here. And it's just less than, so it's got to be dashed. Now it's less than, so that means I got to be underneath it. Now, this next question is why the book will never tell you to graph above or below. This is kind of my own theory of shading. You'll never find this in any textbook because my above or below fails miserably on this graph. X is greater than 2. Now remember, that's a vertical line right here at 2. And it's greater than, so it's just a dashed line again. But it's a vertical line. There is no above or below that. So I can't think of on top or underneath the line because it's a wall. So now greater than 2, but the numbers always get bigger going to the right, so this is where I shade to the right. Now if it were something like x is less than or equal to negative 1, it's less than or equal, so it would be a solid line and be right there. And since it's less than, it'd be over here. This is this graph. Okay? And that really ends up the 5C part with the notes. And like I said, there'll be a third part with me showing how to use MyLabs Plus.